So here we go. Shell scripting. This one, uh, this one's actually not really as difficult as it might seem at the beginning. Um, what I'm going to ask you to do lab-wise is just remember all of the things that you've done prior in this class and then put it into a script so that the computer can handle running all of the individual commands as many times as you need it to do that. So the whole purpose of a script is to be somewhat portable and contain a bunch of commands that you want to see the result of. The last script I wrote was a super simple one. It was like 5 lines, and the whole idea of it was to query my CPU current speed, my CPU current voltage, and my CPU current amperage. That way, I could see the current speed it's running at, obviously, but I could take the amps times the volts and figure out how many watts it was pulling from the wall. So those were just 2 things that I was doing as I was playing around with some of the values in the BIOS. I wanted to keep an eye on what the CPU was doing. To be honest, it was actually pretty simple. It was lscpu grep mhz, I think. There you go. So the current speed of my CPU is 2693. So 2.6 gigahertz essentially, 2.7 gigahertz give or take. The VM might have it locked, but mine would change. It would fluctuate anywhere from 1.5 megahertz all the way up to 3.2. 1.5 gigahertz up to 3.2 gigahertz, and that would I just needed to know what that value was. So that is really all you need to know to write a script, right? Stick this on top, and then in the next line, put that there. And then every time you run the script, that's what pops out. Well, that doesn't seem too terribly intuitive or necessarily why you would want to do that, but the things that I was needing, I needed to run 3 separate commands for. So the whole point of this thing was to, every single second, I wanted to know what the current values were. So running 3 separate commands every single second, viewing each individual one of the values, and then making an assumption based off of that, it's kind of tough when you're having to manually run all those commands. So I'll give you an idea what, I'll give you more information about this here in just a little bit. So let's get through some of the basics of what you want in a script. So, and I'll write this script, so I'll show you what I'm talking about. Let me do this real quick. This way I can give you even more information about it. So Sensors is a way to, is a program that will query your, the files that are associated with your hardware. And sensors, oh no, there's no sensors. Well, that's probably because it's in a VM. No sensors. Okay, well, that breaks that. What I will do though is I'll push that script to a GitHub repo or something like that when GitHub decides to come back, and I'll share that with you guys so you can see what that script looks like. But it was basically something like, I'll just write it. I'll write the script. It's not that big a deal. Okay, so the first thing that you really want to do is name it. So open up Nano or VI or whatever text editor that you care about, and create yourself a file. Whatever you want to name it. That the script that I had written was called CPU hertz.sh. And the first line that you want in there is bin bash. So this line, you don't actually need it. But it's good practice to put it in there, and if your shell is ever curious about if it has multiple shells installed and it doesn't know what shell to use for you, this is to define what shell to use. If you only have bash installed, obviously it will use bash. But this is kind of for you, Brazos, because you installed fish. There's nothing wrong with it. You can use, you will want this line up top. This way, nothing that you write will be different than what you expect. Because I use Fish as well. I wrote the script that I wrote in Fish. It's not a big deal. Just make sure you have that line up top. So it's not important to most people, but it is very important to some. So long story short, write it every time, and you'll never run into an issue. So my script called cpuhertz.sh. Let's do this. If you've ever taken a programming class of any kind, you'll know what this is about to do. Hello World is basically the very first thing that you ever do in pretty much any class, and all it does is it prints to the screen Hello World. So yeah. Anyway, let's look at this. So you can see cpuhertz.sh. I'm gonna run this. Look at these permissions. Why will that not work? Permission denied. It's my file. I own it. I can read and write to it. Why can't I run it? Any clues? Maybe? So we've been harping on permissions for a little while. And the big thing here, make it smaller, man. Yeah. The big thing here is the execute bit is not present. So if you're running a script, you need to have the execute bit. So I'm just giving myself the execute bit, user plus X, instead of just a plain plus X. That gives everybody the privilege of running this thing. And if you look at it again, changed colors. So be aware that if you're getting permission denied on a script that you wrote, it's probably because you don't have the execute bit set on it. So now, if you noticed last time, that dot slash basically says the thing that you're trying to do is right here, and since it's a shell script, it will try to run. So if you're trying to run a shell script that is in a directory that you're in or something like that, you'll need to start it with that. And that's what it does. All it does is print hello world. So we can keep playing with that and integrate the thing I was talking about a second ago. So that was, what was it? lscpu grep mhz. Save that. Let's run it again. That's what it does. It'll tell me hello world, then it will run the command I told it to run and only give me the output. You won't see the command that you tried to run because it's kind of irrelevant, right? When you're writing a script, you don't care about the command, you care about the output and what that means. So, oh, wait, there. And then we can just keep adding to this. So what I wanted was, what was the deal? See if I can remember how to, what I was asking for. It was like, oh man, I cannot remember. But it was sensors, grep, like, and it was basically voltage. And then there was sensors and grep. Something like that, right? I can't remember the name of the actual value itself to grep for it correctly, but that's basically what the script was. So I would get rid of that. Just have that, and that would be good enough. If all I wanted was to be able to run this script one time, just one time, then it would be perfect. But it's not perfect because I wanted it to run a bunch of times. But before we get into that concept, let's learn a little bit more about what's going on. So, I don't want to save that. There, because that is actually not the right command anyway. So, anyway, that's the deal, right? You write something in there, you run it, and it gives you whatever it is that you asked for over and over and over and over again. Ooh, let's throw one more thing in there. Just a simple command of date. Run it again. There you go. And this will just keep track. But notice, if I want it to run a bunch of times, you pretty much just have to keep running it over and over and over and over again. So I'm going to show you guys how to avoid that. Anyway, so a lot of scripts are going to want to take input from a user, right? Think apt when you're trying to update stuff. What is the first thing it asks you? You run apt upgrade and hit enter, and it goes through all that stuff. What does it ask you? Are the changes I'm about to make okay? And then you say yes or you say no, whatever it is. That's what we're asking for, right? So when it asks you that question, this is what it's doing in the background. Now, apt is not just a script, though, but if we were to create something like it, this is how we would do that. Read variable basically says stop and wait for input from the user. And then if you want to call it, if you ever want to deal with it, you'll need to stick a $sign in front of it. So what I mean by all of that, so we can do read, and we'll just call it variable, why not? And then echo variable. Oh, hang on. Actually, before we do that, that's fine. So save that, and we'll go back and talk about what this means and all that. Right, so it doesn't say anything because we didn't tell it to. We're not there yet. But if I do ASDF, give that, and then it told me, here's the variable you chose. It just reprinted it out for me. So let's go back in and see what that's about. So read variable. The read command basically says stop everything and wait for the user to give me input, whatever that may be. I don't care what it is. I just need input, right? But the user will have no idea what kind of input you're asking for unless you tell it, right? So echo what? Oop. And let's change this. Oh, I really hate that the Mac does not have a delete key. This is annoying. I think we might be able to get away with that. Maybe not. It might literally just print variable. All right, so let's run that real quick. Sure enough, worked. So that's what that read thing is all about. So I'm not going to necessarily ask you to go in and do a lot of this stuff, but the idea is that you need to know how they go together, because stringing together commands like this is really going to help out in terms of speeding the process up. And if you hate PowerShell, it's a bit easier than PowerShell, I think. All right. So getting out from input, we can talk about decision constructs. So this is basically anytime you are at a crossroads in terms of a program. So just kind of assume this variable, right? We want it to be a name, obviously. What is your name? If you give me a string of numbers, the idea behind these constructs here is that it would check that, find out whether or not it's made up of letters or not, and then if it's not made up of letters, give you an error and say something like, your name cannot possibly be made of only numbers or something like that, right? And then ask you your name again. So this is how that's going to work. So you have these constructs. This is the if statement. So if is basically, if this is true, then do this. That's how that's going to work. But it might not be that you only have one or the other. You might have, if it's true, then do this. If it's false, then do this. If we don't know if it's true or false, then do this, right? So you will have if it's true. Otherwise, maybe something else is true. And let's say it fails both of those. Then this last one, else, will take precedence. Now, the cool thing is you can have as many elifs as you want. So basically, well, we're going to hit a guessing game right here in just a minute. And that's actually how it works. So you know what? I'll just use that as the example. So this is what we're talking about. So we have an if statement right there. So rando is a number that we chose, or I'm sorry, that is randomized, that got created. And we're trying to find out whether or not it's equal to this number pick. So you can kind of see how this game is going to work. At the very beginning of the game, a number is randomized between 1 and 10. Then you are asked to pick a number between 1 and 10. Right? Here's that read pick. So it's waiting for you to choose that number. And then here comes the construct. So it says, if the random number generated is equal to the number you picked, then you win. Cool. Now here's where it comes in. Otherwise, or else, if the random number is less than the pick, then too high. Now, we have the number was too big, the number was just right, what's left? And that's where this comes in, right? We don't have to make a comparison here. We don't have to say if rando is greater than pick, then obviously too low. We don't have to do that because that's all that's left. All that's left are numbers that are too low. So you don't even have to bother telling it exactly what you want because obviously that's all that's left. So we'll play this game here in just a minute. This is the thing that actually lives on GitHub, but GitHub is dead for now for some reason. I don't know why. Oh, yeah, no, it is. So anyway, I'm going to keep trying it. Maybe it'll be back up by the time we're done. Anyway, so you close off this statement. So you open it with if, and you close it with phi, which is really just if backwards. And then whatever the number is, we print it out. And then you want to exit 0. The idea with that is that you're telling the command to stop once it gets to that point and give a result of 0. And if you remember to your standard output, standard input, and standard error, what is standard output? Well, I guess the better question would be, what is standard error? So the long and short of it is basically, if you have nothing to report, you report 0. So 0 is basically a thumbs up. So this line basically just says, yep, close the program properly and let the system know that it ran just fine. So it won't log it. Okay, so that's it. That's what an if statement's about. That stuff right there. So let's look and see what this actually does, how it behaves. So let's see. Let's just do gg.sh, guessing game.sh. And I'll try to write this as best I can. If I make a typo, you guys are going to have to help me debug it. Rando equals. So yeah, please pay attention while I'm doing this so you can catch if there are any typos here. And I'll explain what this particular line does. Yeah, it's a bit of a math thing, but don't worry too much about it. I don't need you to know math, but this particular concept bears some repeating. Enter. There we go. Read pick if rando close that off. All right, that should do it. Find out real quick if I typoed. But you guys are on the hook. You'll have to fix it. So make sure to apply the execute bit to this thing, and then let's run it. Yay! So at least I got to that point. Pick a number between 1 and 10. Let's just go straight down the middle and go 5. Oh, wow. I win. Ha! That's awesome. The number was 5. See, my middle of the road ideas, they work. Okay, hold on. Nope. Okay, wow. That was total luck. It was 5 twice in a row, and I picked 5 twice in a row. I won my own game twice in a row. What was that's a 1% chance of happening. That just happened. That's cool. Anyway, keep going, keep going. And you can see. That's what it's doing. This whole construct craziness right here is working. So let's do this from top to bottom. I'm going to explain every single thing that's happening in this entire thing. And if you look, it really only generates three lines. You wrote what, 12 lines, 8 lines, 10 lines? To output about 3 lines to the user. Okay. Oh, no. All right, so let's look at this. First line, bin bash. If you encounter this and you're not running in bash, run it in bash. That's what that means. This little thingy is called a shebang. I didn't name it. Don't blame me. This is just the very first iteration of this guessing game. It's just a comment. Just like in every configuration file you've ever dealt with, a hash mark denotes a comment. All right. This is the hardest line to understand in the entire thing because it has to deal with math, and most people hate math, so they kind of tune this out. So don't tune it out. Pay attention here. This is important. So rando, number 1, the first thing that we're dealing with here is that we're initializing a variable. So just like we did up here, right, we're literally just saying this. Variable named variable contains the number 12. So if we ever do like echo $variable, it will just spit back out at me 12. So in this case, what we're doing is rando equals, and this should look a little familiar, the $bracket, command substitution. So the result of this command is going to be assigned to rando. Long story short, it's going to pick a random number. So there is a random variable. This exists. You can actually call it. So if we do echo random, we get a number, right? Cool. And you can just do that over and over and over again. It'll be a different number every time. Right? Well, those numbers are way too big. I'm not going to try to ask you, hey, pick a number between 1 and 65,535, right? That game is a little tough. So instead, what I'm going to do is divide it. I know that is not the division symbol, but it kind of is, right? It's that slash, but yeah, close. It's a percent sign. So here's the deal. You remember back in like 2nd grade when you weren't dealing with decimals? When you did long division and you had leftovers, what was that? Oh, for a second I had a brain fart. I forgot what it was called. It's called a remainder, right? So if you take 1,111, so 1111, you divide that by 10, you're left with what? After the long division's over, you're left with something. And that's a remainder. That remainder in that case would be 1. Right? So look, let's do that real quick. Well, actually, I don't actually know how to do that. In the calculator, that is. I don't actually know how to do basic math on the command line either. Because, yeah, what I wanted to do was show you how to deal with that. But, well, let me show you what this is doing. Yeah, I guess that would work. Right? Echo. Random divided by. Oh, wait. I need to quote it, I think. No, it's taking the number. See, now this is, I just never do this. I have no idea. And that wouldn't work either. This is how often I just do straight math in the command line. I don't. So anyway, let's do it with 11, right? So 11 divided by 10, yeah. 11 divided by 10 is 1, and you have 1 left over. So when you're doing this, all you're asking for is the leftover. So take 12, for instance, right? 12 divided by 10, you get 1 with 2 left over. So this percent sign says, I want the 2. I want the remainder. I don't care about the other thing. Just give me the remainder. So the whole point of this is to take that multi-digit number. It was like 5 or 6 digits each and every time. Divide that number by 10 to get the remainder, and then add 1 to it. The reason I add 1 to it here at the back is because the remainder might actually be 0. And I'm not asking you to pick a number between 0 and 10. I'm asking you to pick a number between 1 and 10, right? So anyway, so just in case the remainder is 0, I want a 1. And if the remainder is 9, that will push it up to 10 so that it's part of the game, right? So 10 might actually be an answer. Okay. So that's what I'm saying. This is the hardest one in the whole script because of what it does. And I can't just skip over it, otherwise, everybody will have questions. So anyway, the random number divided by 10, take the remainder, add 1 to it. And then at the end of all of this, that's what rando is. Rando is the result of all that. So when we say rando down here, it's like 5 or 8 or 1 or something like that. All right. So now we can safely ignore this line. This, all it does is echo, so it tells the terminal to print out this phrase. This E says, do not do a carriage return. So basically what it's saying is, I want you to put your number over here, not on the next line. So anyway, pick a number between 1 and 10, press enter. And then the next thing that it does is it waits for you. Whatever you're going to write into that, whatever you're going to write into the terminal is going to be saved to the variable pick. So now we have a random number, and after you've chosen it, we have pick. So now we can start doing some comparisons. So if rando is the exact same thing or equal to pick, then you win. So hopefully this is starting to make just a little bit of sense. Takes a little while to fully get and grasp all of these constructs and what they do and why they are, but hopefully it's starting to click just a little bit. So this random number is equal to pick, whatever the user chose, then you win. If rando is less than pick, too high, otherwise too low. No matter what, after the construct, we close that up. No matter what, display what rando was, and then exit. All right. So that should do it for a very simple script that contains a construct. And this will go with pretty much anytime you have a question, anytime you want to evaluate something, anytime, yeah, you just kind of come up to a crossroads, right? Like where it could be more than one thing, you'll want to use a construct like this. So we saw less than and we saw equal to. Those already exist. You've already seen them and what they do. Here are the other ones. Or, and, not equal to, greater than or equal to, less than or equal to, modulo. Oh yeah, we saw this. Its special name is modulo. And then not. So if you have a statement that's true and you stick a not in front of it, it becomes not true. Or at least it tries to see if something is not true. So you can have something like 1 is not equal to 1. That is obviously false, right? So that would come out as false. And then you might also want to look into some other things, right? Like you can have something like if, let me see, bin fish. So you can have something like this, right? That if the fish shell exists in the bin directory, then do the next thing I tell you, right? Like the next line, which would be this. Or you can say something like switch to, or just run it, right? Like you can just run bin fish and it will change your terminal or change your shell. So this is just making a comparison. Does it exist? This file here. And these other ones do the same exact thing, but they're looking for specific stuff, right? Does it exist and is it a directory? Does it exist and is it a regular file? Or is it readable? Or is it writable? Or is it executable? Or is it this? Is it empty? That's the idea here. So if it's empty, it will fail. It will not be true. But if it has even one single byte, it will then be true. It'll evaluate as true. So I'm not going to make you do this, but there's the idea of loops. So I was talking about before, I had this script that I wanted to rerun every single second. I used a while loop to do this because I didn't ever want it to stop. So there are two types of loops. There's a for loop and a while loop. This is probably the hardest concept to me when I was taking my programming classes, when I was doing all of that kind of thing, because both of these things will just do stuff forever. But there's nuance there as to why you would choose one over the other. So a for loop, this will do something for some specific amount of time. That specific amount of time might be infinity, right? Like you can just set that loop to go forever. But a lot of times, and in this particular example, what you're doing with a for loop is saying, let's say there are 10 files, and I want to find the word CPU or the acronym CPU in all of these files. You will do that. You can do that with this, and once it's done with all 10 of those files, it will stop. That is the end of the for loop. It figures it out by itself. You don't necessarily have to go and explicitly tell it, all right, here come 10 files. After the 10 files, I want you to stop. The for loop will figure that out because you literally gave it 10 files, so all it can do is look through those 10 files. So it's slightly smart in that way. But, you know, it's only as smart as you program it. So, to be honest, it's as smart as you. So, anyway, for var name in blah, 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 blah. And this just means string 3, string 4, string 5, string 6, string 7, string 8, string 9, right? So, what it'll do is you can just stick like 10 in here. Or you can, well, yeah, really, that's pretty much it. And then in these files, it will do this, like you'll do grep CPU. So it will quite literally just go 1, is it in there? No. 2, is it in there? Yes, and I'll print it. And 3, is it in there? No. 4, is it in there? No. 5, is it in there? Yes, and then print it. So it will find for you the exact amount of the word CPU showing up in that thing. And then you can like pipe that through number line or something like that so you can get an exact number at the end of it all. But the basic idea of this is that you give it a certain number of files or numbers or things to do as part of the loop itself, and then you just tell it underneath here what you want to do with it. So again, I'm not testing you on for loops, so I mean, just get the general idea of what this for thing is about. Now, while is how I did my script, right? I never wanted it to stop. So what I did in my script is, I'll just write it. Nano, what was it? Yeah. Let me get rid of all this. So I did while variable x equals 0. Well, a lot of people put do down here, indent this, and then done. And then at the very top, oops, I just said x equals 0. Okay, so looking at this and seeing this script, I'm going to wait for you guys to answer on this one. When will x ever change? Looking at all this, is there anything that manipulates x and would change it? Did everybody fall asleep?
If it is not equal to 0?
Correct. It is not equal to 0. So when will that ever not be true? So will x ever be 1? Looking at what's happening in the script right here, will x ever change?
No.
correct. So when will that ever not be true?
Never.
Exactly. Which means that this script will run forever. So I was talking about earlier, making something run forever. Well, this is how you do it. You say x equals 0, and then you say while x is equal to 0, do this thing over and over and over and over and over again. And then it'll just keep going. So I made my window really, really small, and then it was just a little window on my desktop that gave me the updated version of whatever it is that I needed. So it's just a nifty little way to make things happen forever. Let me see. I'm sure there will be a typo. I'm sure I broke it somehow. Nope, there it goes. Oh, I forgot to put a sleep on it. That was the last thing. So yeah, it'll just keep going forever. Control C to break out. I'm happy that it worked. Here. And then, because that was crazy, sleep 1. And we'll do that. Now, oops. Quit that. No. Control X. Thank you. Yes. Okay. So now when I run it, there we go. Every 1 second, and actually because the date is in there, you can see it's actually 1 second. Obviously, the CPU, the multiplier is locked. So yeah, that CPU speed will never actually change. So what I ended up doing was that. But since the CPU actually changed, that number would actually update. But if I did this, there. So it's not the fanciest thing in the world, but it does show you how a while loop works. And a lot of times what ends up happening is people will do like a counter, in here. So, that kind of begs the question, well, how do you stop a while loop in the first place? So what you could do is you can say x equals 25. X equals x plus 1. I think that'll work. I haven't dealt with that in a little while. But anyway, what you're doing is like every time it goes through the loop, you're adding 1 to x. And then when it finally makes it up to 25, then it will stop. I don't know. No, it broke. So I'll need to figure out how to do basic math. So I obviously cannot do basic math in the command line, but that's kind of the idea. Oh, you know what? I do it down here, I think, don't I? Maybe. Oh, that's it. $. So if I come back in here, x equals, there we go. This will probably do it. Maybe? No, I broke it. Oh, nope. It's because I'm an idiot. That needs to be 0. It needs to start at 0. Because what was happening, this is what I was missing the whole time, was that if x was 25, then x is already 25, so it'll just do the loop 1 time, and then it'll quit. But if x is 0, then now it'll count up 1 every time, over and over and over again, and move up. So, yeah. See, debugging can be fun. Oh, see, now I totally broke it. So anyway, by the way, this is the kind of thing that you're going to have to go through. You will get the chance to deal with this. And so I'm going to put this to the side for a minute, but at the end of all of it, I want to actually fix it so you guys can see how this is going to work. But anyway, so we'll put that on the back burner for now so I don't waste too much time doing it and get through the rest of the lecture. And then we'll come right back to it and figure out why the heck that doesn't work. So anyway, here's the deal. Here's the second version of this game. So we didn't change too terribly much of it, right? By the way, you can do a diff on this. This is a good time to do that. So diff is a command in the command line that will basically look at two different files and tell you what the difference is, right? Because this first line in my original file will not be different than this line. But this line will, because the 1 over here changed to a 5 over here. Anyway. No. All right, so we still start with rando. And I don't know why I lowercase them down there, but I uppercase them up here. I'm going to keep them uppercase. Variables tend to have uppercase letters, so I'm just going to leave it like that for now. Okay, so that didn't change. Get out of the way, WebEx. That didn't change. Echo E didn't change. So we add the while loop here. So while. Oh, no, I see what I did. I turned this into a while loop. So while read pick, I've got it here. You can put it here if you want to, but in my last example, I put it here, and then we'll just indent all of these lines. So while read pick, don't forget your semicolon here. While read pick, do, and I didn't change anything there. It was random equals pick. Yep. You win. Okay. So here's the deal. In a while loop, if you want to ever stop it at a certain point, right, you will write the word break. And this is a signal to the while loop to just stop. We've gotten the result that we wanted, stop, and then move out. So we don't, so the whole deal with this, right, is that I want this to continue going until you get the number right. The previous game generated a number, compared your number, and that was it. So you never actually got the chance to keep guessing until you got the number right. So that's what we're trying to do here. We're integrating a while loop so that while you are wrong, it just keeps asking you the question over and over and over again. It's like a game of hot cold, right? So only when you win does the game stop, this break line. So the rest of the stuff is going to be the same. Rando less than pick, then echo too high, else echo too low, phi. And then we want to end the while loop. And then the rest of it stays the same. All right, assuming I didn't make any typos, this will work. Okay, 2, too low, 5, too low, 7. The number was 7, yay, and it breaks me out, right? So it just lets me keep guessing over and over and over again. So this shows you how a while loop is going to work. While we are getting numbers from the user, do this stuff. The only way to get out of it is to win the game. Because once rando equals pick, so once the random number equals whatever you pick, then we get a break, sends us straight down to the done, and then it displays, it displays this, and then it performs this. Tells the system that this script exited successfully. You don't have to have an exit 0 there, but it's nice to the system. All right, so that integrated a while loop. Now I want to keep score. So we're going to add a little bit of code to this. Hey, look, I think it's, oh, hey, cool. Okay, after that weird little glitch. So you can see inside of here, here's my guessing game. README file displays it right here. Oop. Displays it right here. This is really just Markdown. Let me see if I can find, raw. Yeah, that's what the text actually is. You can do this in Nano or anything else that you want to do it in. I'll show you. And then also this, the guessing game. So this is actually what I'm about to write because it's got the guesses counter and all of that. Initializes guesses up top. And then you can see the history. So the first beta, this is what I literally typed earlier, the very first time we hit this game. The second beta, this is where it is right now. And so these red lines are basically things that were removed. The green lines were things that were added in its place. Look at this. Line 2. Line 2. So the red is gone. The green is there now. Line 3. Line 3. That's gone. This is there now. Oh, I see what I did. I made it lowercase. I should probably fix that. But anyway, that's the idea, right? So the red's gone. The green is new. White was not changed. And it just gives you the history of what's been going on. And then you get your final release. Not a lot's changed, but a few things were added, like the guesses. All that. So let's add that real quick. Oops. All right, so Nano. How did we do this? Let's see. So right underneath rando, I initialize guesses, and I set the counter to 0. So basically your score is 0 at the beginning of this game. And then as we go down, oh, I see what it is. So what we're doing is we're adding guesses equals $, guesses plus 1. Okay. And then done. Okay, all right, so I will let you know everything that I've added, what I've done here. If you're starting to get the hang of this and you kind of know what I'm doing already, then great. Oh. Okay. Barring typos, that should work. Oop. Also, version 1.0, yay! So, we added this, so we're basically initializing guesses and setting it to 0. So like I said, your score is 0 right now. And then every time that it goes through this loop, notice the done here, right? This is the end of the loop. So it does this every time it goes through the loop. So guesses basically equals guesses plus 1. So 0 is what it is right now, plus 1. And you go through the while loop again. Guesses is now 1, so you add another one, and it's 2. And then you go through the loop again, then it's 3. And you go through the loop again, and it's 4, and 5, and 6, right? That's all it's doing, is it's keeping track of how many times you've gone through that loop, so it basically it'll keep score. Now, this one, remember that when it breaks, it stops. So if it goes through this, and you get to this break, it never makes it down to add 1 to guesses. So if you get it right the very first time, it's going to say that you made 0 guesses. So yeah, we can't have that. So at the very end of it, we do that again. So after the while loop is done, tells you what the random number is, adds 1 to your guesses, and then tells you how many guesses it took. All right, so save this. Let's run that and see how that actually works. So, all right, pick a number between 1 and 10. Number 1, too low. Number was 7. 7 guesses total. That's all it was doing. Going through over and over, doing a counter, and then keeping track. Okay. So what I'd like you guys to do is write this script for yourself. Or go to GitHub and copy and paste it, I don't care. Or from the notes, copy and paste it, doesn't really matter. But what I want you guys to do is to actually go through that and read those. Make sure you understand what it's asking you when you do it. Or what you're telling in the script, what you're telling Linux to do. Make sure you at least have a pretty decent idea of what you're doing. You may not be able to go super in depth about what it is and why, but know what it's doing when it says, read pick or while read pick. Know that that's a loop, and then it'll keep going and going and going and going until something is done about it. In this case, break. So here's the deal. Last little bit that we're going to talk about today is Git. It is super simple to take the code that you have written here, right, and move that to Git. So here's the deal. Git is version control. It is basically there as a repository to maintain a bunch of text, really. That's really what it's about. So when we went over here, you could see, right, all of that stuff. This is what Git does. And there are command line tools that will allow you to push additional code or even changes to this code. This is what happened here with this history, right? I pushed the initial one, then I pushed the second version of it, and then I pushed the final release of it. And now, anytime I need to, I can take this and give it to somebody. I can tell somebody, here's the code, go check this out, here's what it is. So you can come in here and see all of those changes, all the commits, all the things that have happened. One sec. All right, so the deal with that is so that you can maintain a repository of code and point people to it. The whole idea with this is that if you're working for somebody that has your scripts or that you need to maintain some stuff for, this is what it's great for. The cool thing about it is that, like I said, through the command line, you are able to download each and every one of these things and then straight up use them. So let's look real fast at what you're dealing with in this case. So if you look in this machine, I go to CD documents git Leo Chavez at TSDC. So that's basically just my username on GitHub. You can have multiple repositories. The repository that I'm dealing with right now is called Git Basics. So this is me, and this is one of my repositories. I don't know that there's any limit, even on the free version of Git, to how many repositories you can have, but yeah, I don't think so. Go to repositories, just click new, add a new repository, and then start putting stuff on it. Yeah, so just keep making repositories. One of the cool things one of the other cool things that you can do with Git is just maintain a set of notes. If you don't want to maintain an entire website, but you want to remember some things about Linux or about the machine that you have or any of that stuff, you can just maintain notes in Markdown. So if you look, readme.md, all this is let's just create one, is Markdown. And this is right? I mean, that's all that is. And then it will look like this. The heading will look like that. The text will look like that. There is let me see, it's like flaming something or another. Yeah, so if you want to bold stuff, you do it like that. It's just a way to write quick notes, essentially. Anyhow, um, we'll mosey on through this. So you guys aren't going to be labbing on this just yet, but I want you guys to have the way to go through it because we're going to be dealing with it next week for the final. But like I said, just come in here, look at these things, run the commands the same as I've run them. Obviously, change the URL to your name and your repository and your file names, things like that. But the commands themselves will be the same. So let's take a look at what we're doing here. So git clone that. So what you're doing here is you're just saying, give me an entire copy of that repository. So if we go do that, I think Git is automatically installed in Ubuntu. Yep, sure is. So you can say, let me go get that repository name. So there's that. Oh no, I don't think I'll be able to do that. I'll just type it out. It's fine. So git clone HTTPS. There's no www. And then if we do LSL, you can see now that I've got a Git Basics directory. So if we go into it, you can see they're the two things inside this repository, right? So all you're really saying is just give me all those files and put it in the same name directory as the repository itself. All right. So nothing too special there. Then if you want to make changes, we'll say that, right? We'll add that to the file. Now that doesn't actually do anything except for edit my version of the file right here. That's all it does. So what you can do after you edit it is git add readme.md. So what you're saying is locally add readme.md to staging. You can basically say that I'm getting ready to push this file to GitHub and update it. So once you're done making all your edits and all that kind of thing and it's in staging, you commit it. So at this point, there's no turning back. Well, there is turning back, to be honest, but this is you're committing pretty much at the point where you are ready to push the code. This is the last call. You ask, hey man, sanity check, can you look at this? Make sure I didn't make any mistakes on it or anything like that. So let's do that real quick. Git add readme.md. Git commit. M is basically just a comment. Additions after lecture. Oh, whoops. I totally forgot to do this. Set your username and your email address. So git config global user.name and then Leo Chavez. And then git config. There's that. Pretty sure that's right. And then so now we can come back and git commit. There we go. So yeah, don't forget to add your name and your email before you do what I tried to do. All right, so git commit im add. That's just a comment there. So that's all I did here, just some additions. And then we're gonna git push u origin master. Okay, so origin is basically just your repository itself, the original repository, and then to the master branch. So you can have multiple branches of code. You can have essentially, like if you think about software development, you have betas and alphas, and then you have these stable releases. Those are three different branches that you can have. So you can have the master branch, which is the stable branch, or even maybe the alpha branch, right? This is testing or something like that. And then you would have a stable branch. That way, stuff that you know for sure definitely 100% works, you push to the stable branch. And things that you're testing, you'll push to the master branch. And the only difference is you would do git push u origin stable or git push u origin master. But in this case, I only have one branch, so it is master. It's going to ask me, what is your username? Yeah, Chavez at TSDC. And then my password. Done. So one of the things that we can do after this is, so this is what the README file looked like before I messed with it. Looking at it again, now that's what it looks like, right? That time is a little weird. 2 minutes ago. I don't know if it's 2 minutes ago, but that's the idea. That's how you're gonna do this kind of stuff. So the great thing about this is there are tons of people that have written tons of scripts and just code in general, programs, Python, different programming languages. And Git, at least GitHub or GitLab, are the two big places that they store it all. This is kind of the idea of open source. You're meant to go in and look at the code. It's the whole point of this. Go find it. And then you can take this. You can literally copy and paste it. That's fine. But you can also just go in and download it. Or you can also go in and try and make changes. I think that's the beauty of Git, is that more than one person is totally meant to be able to write this code and make changes to this stuff. And then when you do a git push, you can set it up to where there is one guy up at the top that approves all posts, or that approves all changes. And if your changes get approved, it gets added to the game. And then you'll see history. You'll see, I committed. But the next time it might be somebody else. And the next time it might be somebody else. And then I come back and commit something, yeah? Back and forth. That's the whole idea of Git. This is a new topic, by the way, for the Linux Plus test, which is weird. But anyway, some other... Oh, yeah, no, that's pretty much it. This is just an explanation of all the commands, all the Git commands that you saw up here. So if you just want to read it and not hear it. And then you can see me doing it, right? So I nano guessing game, I make my changes, I verify that it's there, and then I add it to staging, I commit it with a comment, and then I push it. And you can see it happen. And then same deal, I make the second beta, and I push it. And I make the final beta, or the final release, and then I push it. You can also see Git status. One of the cool things about Git is it will tell you you're dealing with the master branch. That's where you pulled it from. It is up to date with Origin Master. So if I were to do a git commit and then a git push, nothing would happen. Nothing to commit. The tree is clean, meaning I've not made any changes to my local files that do not match the files that live in master. So that's basically the idea with all of this. If you want Git to ignore some files, maybe you have notes that you're taking, like mynotes.md. Oops. And you do not want that to get pushed. You will create a file called gitignore. You do have to put gitignore in here. So you have to tell gitignore to ignore itself. You do have to do that. So mynotes.md. I think that's what I named it, right? Yeah. And so anytime you do a git commit and a git push, it is not going to add this file or this file to that commit. That way you don't dirty up the branch with files that are yours and yours alone. So anyway, that's kind of the idea with all of this stuff. So keeping track of all the junk that you do on a day-to-day. Think about it like this. If you make changes to a single file on a server, but you want those changes to be copied out everywhere, you probably want to do something like Ansible. But in lieu of that, you can just put all those changes in GitHub and then git clone that branch and then copy over that file everywhere you need it. You don't necessarily have to make changes with Git. You can just make copies of files with Git. That makes it pretty decent. So anyway, the only thing I'm really going to actually test you on, and this will be next week, is go create a GitHub. I don't care what your username is. Please, nothing vulgar. And then create yourself a repository. You can come up here, click on your little icon, go to your repositories, and click New. It will walk you through the process of how to do that. All right, you give it a name, you tell it what it's about. I need you to make it public so that I can go in and see it. Then create yourself a README. So as I was showing you those the basics of Markdown, README is set in Markdown, which is just a way to simply write some stuff. And then do you want to git ignore, and do you want a license? You don't have to have either of these. A README, you do. And then create your repository, and then it will look like this, right? There will be a README file in it, but that's it. You won't have any kind of files or anything like that in it until you push something to it. So get to this point where you have a branch, where you have a master branch, and you have a README file. Put anything you want to in that README file. Again, nothing vulgar. And then work with it that way. The script that you're writing this week is going to be what we push to your branch next week. That will be a test grade. I hope that sounds easy enough. Or at least, you smack your forehead on the keyboard for a little while. Easy enough, right? As long as it works at the end, that's going to be your what will essentially turn out to be your midterm grade. We didn't have a midterm in this class. There's a final and a midterm slot, though, and final and midterm constitute 40 points of your total grade. So if you can manage to git push your shell script to GitHub, you get 20 points on your final average. Yay! Right? That cool. And so the last thing I will tell you guys is the other half, the final part of your final, is going to be just a multiple choice quiz. That is going to be the majority of what you see on the Linux Plus test. There will be questions like I've been asking you throughout the entire semester, like if this, then what? What is this? What does this mean? What is, what kind of option would you give it? Something like that. You'll see a lot of those. But the majority of what you see will be multiple choice questions. So, to that end, your final will be multiple choice questions. The deal with it is going to be that none of it is new, right? There will be no surprises on this final. Everything that I ask will be something that I have asked prior. And if you want a study guide, crack open that book and look at the do I already know this quizzes, the ones that show up before the chapter starts, and then the end of the chapter. There are questions. If you know those questions, you will ace this test. There it is. There's the path to 40 points. Push something to Git, know the questions in the book. It's been a rough road, but we've made it. Finally made it to the end. So, that's it. Do y'all have any questions? All right, I'm going to kill OBS before it